Hello, North Haven Middle School 8th grade algebra students. This video is for you. We're talking about the last topic within our radical unit, the first thing you did after your exponent test. This is the last radical topic we're going to cover, addition and subtraction of radicals. You should have already seen simplifying radicals in 11-3. You should have seen multiplying radicals in the 11-4. 11-5 was two parts. That was dividing and simplifying radicals, but that had rationalizing the denominator within it. And the 11-6 worksheet, this is addition and subtraction radicals. This is a lot easier, in my opinion, than rationalizing the denominator, the thing you probably just did. I think that's the toughest part of the radical unit, so this video should be a lot easier. All right, this is take 2 of me filming it because I just filmed this entire video and realized I had my cell phone locked so it wouldn't auto-rotate into landscape style because me and my son were riding virtual Disney rides earlier. But now it's all checked out and it's all going to work out. So anyway, addition and subtraction of radicals. I wrote under here, this is kind of your key. Think combining like terms because that's what you're going to be doing. When you're adding and subtracting radicals, you can only add and subtract like radicals. So instead of combining like terms, we're going to think combining like radicals. You can only add things under the square root with other things over the same under the same square root and under the same radical. I'll show you exactly what I mean right now. Would have been nice if I had something written under there. Anyway, here's why I mean these are so easy. If I have 3 square roots of 5 plus 4 square roots of 5, or 3 radical 5 plus 4 radical 5, yeah, you can go ahead and think along the same wavelength as, okay, this is 3x plus 4x. It's just going to be 7x. Same thing here. 3 radical 5 plus 4 radical 5, it's just going to be 7 radical 5. All right, so that's as easy as they are. They do get a little tougher, obviously. So let's look into the ones that are a little bit tougher than that. So let's erase this and let's do a subtraction example. Let's do radical 12 minus radical 3. So now I have 2 different things under my radical. So you might be thinking, I can't do this. You just said I can only add and subtract radicals when it's the same thing under each one. I did say that. But in earlier videos, especially 11-3 video, simplifying radicals, I showed you how to simplify radicals. So you might be looking at rad 12 and realize, wait a minute, I can break that down a little bit. I know that that is the same as the square root of 4 times the square root of 3. And that's going to be important for 2 reasons. The first being, we pulled out a perfect square. So now this is going to become 2 rad 3. And the second reason being, well, once I did that, I conveniently, for the sake of this problem, now have a common radical. So it's 2 rad 3 minus rad 3. Just like with variables, if there's no number in front, that means there's really an invisible 1 here. So this is 2 radical 3 minus a radical 3. I'm just going to get 1 rad 3 as my answer. And you don't even really need to write the 1. You could just write rad 3 if you want. Just like you can write x instead of 1x. Same logic, same line of thinking. All right, let's do one more example with just numbers before we go into examples with variables. Make this, do a little bit of a trickier one here. Let's do square root of 2 minus the square root of 8. So again, I've been saying like radicals, but by now you might be picking on that, oh, that's how these problems are going to be. We're going to have to simplify one or both of the radicals in order to get that common radical. And yeah, that's what's going to happen a lot of the time. So square root of 2, nothing much we can do there or anything. So it's just going to stay the square root of 2. But 4 times 2 is 8, so we can break this up as 4 times 2. And that's going to be super useful for the same problems, same reasons as was useful in the last problem. I now have square root of 2 minus 2 square roots of 2. I put this problem in the video because it's a little trickier because you might be thinking, wait, I have rad 2. How can I take 2 rad 2 from only 1 rad 2? Well, that's because we can have negatives. It's a thing. They don't go away, even in radicals. So my answer is going to be -1 rad 2. And if I wanted to, I could just write that as negative rad 2. I don't need the 1. If you write it, it's fine, but you don't need it. All right, simple enough. If not, pause, rewatch, come to the extra help sessions that are being held. But let's jump into some problems with variables. So first one, we're going to jump right into the tricky ones. Nothing too hard about this, but nothing basic either worth putting in the video. So now I got rad x plus rad 4x. If you're thinking, oh, that's just going to be combined like terms, rad 5x, well, that is incorrect. That is wrong because, remember, yes, I said combining like terms, but now we're thinking combining like radicals. These are two different things under the radical. This radical has an x under it. This radical has a 4 and an x under it. That's not the same radical. I can't combine these the way they're currently written. I need to simplify one or both of them, and in this case, this is the one I'm going to need to simplify. So square root of x, I'm going to keep as the square root of x. I'm going to rewrite this as square root of 4 times the square root of x. That's going to be really helpful because square root of 4 is a perfect square. So this is going to stay rad x. This is going to become 2 rad x. I have 1 rad x plus 2 more rad x. My final answer is 3 square roots of x, or 3 radical x. All right. So again, a little tricky there. If you're not thinking, you could easily write that wrong answer. If we turn this quiz, which I think there's a quiz or check-in or whatever you want to call it, next week, you'll get this problem wrong because I'll make sure if it's a multiple choice quiz or check-in that answer will be there as one of the choices, and I don't want you to fall for that trap and pick it. So make sure you're thinking when you're doing these. All right, we're going to do one more example of variables, and then we'll do a props to the tops type question to wrap it all up. So square root of 24y plus the square root of 54y. This is the one I'm ending on because this is a problem we're going to have to simplify not one, but both of these radicals in order to get a common radical. Again, 24y plus 54y, if you're thinking it's going to be 78y, that's wrong. I can't do it. I need to have a common radical before I can combine or subtract, whatever the case may be. So 4 goes into 24, and that's nice because it's a perfect square. I'll be left with 6y in the radical, so I have rad 4 and rad 6y. 54, 9 times 6 is 54, and that's convenient because that means I can break this up into rad 9 times rad 6y. So I now have 2 perfect squares, which is going to be really convenient. And the leftover radicals here are both the same thing, which means I'm going to be able to combine what I get. So I get 2 rad 6y plus 3 rad 6y for a final answer of 5 rad 6y. Alright, so that's it for adding and subtracting. I'll keep this video short. Like I said, I think this is one of the easier sections of this radical unit that we've been covering. I think the one a little bit prior, rationalizing the denominator, is the trickiest one. Ms. Khan made a video for that. I have not made a video for it as of this point. I'm hoping I can get to it. But if not, Ms. Khan's is very, very good and explains it very, very well. I'm going to do a quick review of rationalizing the denominator in my last problem of this video, because this video is a little tricky. It's going to combine rationalizing the denominator with adding and subtracting radicals. So we're going to do the square root of 7 plus the square root of 1/7. All right, so again, I have 2 different things under the radical. What can I do to make this work? Well, first I need to simplify something. Well, there's really nothing I can simplify. Square root of 7, there's nothing I can do to that. Square root of 1/7, I can rewrite that as the square root of 1 over the square root of 7. And then after I do that, well, it might be helpful to rationalize the denominator. So again, a quick review of what rationalizing the denominator means that I don't want any radicals in my denominator. I want any radicals in the bottom of my fraction. So I need to get rid of the square root of 7 that's down here by keeping this equal, keeping this equivalent. I can't change the value of this number. So, well, how do I get rid of rad 7? If I multiply it by itself, That's going to be really convenient because then that's just going to become 7, square root of 7 squared. Square root of 7 times the square root of 7 is just 7. But remember, I need to keep this the same. So when you're getting common denominators, when you're working with fractions and you want to keep their value the same but change them so they're easier to work with in the problem, you always multiply them by 1. And by 1, well, that means the same thing on the top and bottom of your fraction. Whatever you do to the bottom, you got to do to the top. Same line of thinking here, even though we're dealing with radicals. So I did the square root of 7 times itself to get rid of the radical in the denominator. On the top, square root of 1 times the square root of 7. That's going to be just the square root of 7. So let's bring that back down here. Now I have the square root of 7 plus the square root of 7 over 7. So now I can do that because the square root of 7, that's the same as 7 square roots of 7 over 7. Again, I'm just really putting a 1 in front. I'm really getting a common denominator. This is more of a review of fractions. So 7 square roots of 7 plus the square root of 7, because there's really an invisible 1 there, is going to be 8 rad 7 over 7. All right, that's about as hard as this stuff gets. So if that confused you a little bit, you can go to the review sessions, but this is the props to the tops caliber question. It's a tough question, combining the rationalized, the denominator, and the addition and subtraction. You're not going to see too many of these, but this is kind of the hard one, so I wanted to make sure I covered it. All right, and that's it. I'm going to keep this video short. It looks like we're just about at 12 minutes. So stay safe, keep washing your hands, log into those extra help sessions, and also just message me, whether you're a blue team, orange team, purple team, whatever team. If you want to get some questions on here, if you want to log on and do a smaller group session, just shoot me an email of a time that works for you and some of your friends. We could do a small group session and go over some of this stuff. And like I said, expect next week. This video I think will be in the week of March 30th. But anyway, before that spring break, you're going to have a quiz or check-in on radicals. So make sure you're viewing this video and getting the extra help that you need. All right, stay safe, everyone, and wash your hands.